Hi everyone. So today we would be doing the third exercise, which is the building the microservices application. So before starting with the third exercise, I'll quickly go over the last exercise solution. So in the last exercise, one of the tasks was to add an extra API which says your group number application deployed using Docker. So it was quite easy. I think the difficult part in this was some of you were using the rest.json over here, but it has to be a simple string message. So that's why one has to specify res.send. The next was for you to deploy your application to using Docker. So for that, you have to write the Docker file. And it's the same as I presented in the last exercise, that you have to first import the base image, then create a directory, then make it as a working directory, then copy the package.json file, and then npm install will install all the dependencies within the Docker container, and then rest copy your source code, and then expose the application on a certain port number of the container, and the last would be the command for running the application. The next was to changes in the docker compose.yaml file. So here it was easy. You have to just add your hub ID, Docker hub ID over here, and then this image repository over here. And this thing was previously also mentioned in the last exercise, that this MongoDB over here, which we are passing it as an environment variable, is using this second container. So it's like a dependency created between the server and the MongoDB over here. And lastly, it was the enabling of the Docker remote API, where you have to just edit one file, the docker.service, and add this information so that it can be accessed by the cloud submission server. And that's all you have to do in the last exercise. Does anyone have any questions or any problems they want to mention from the last exercise? If not, so I'll start with the next exercise. So the next exercise is we are building a microservice application. And for that, we are currently using Node.js. So in the Node.js, there are many frameworks or the toolkits for building it. So one of them is the Seneca.js. So if you like, you can use it, but you can also use other frameworks also. So your solution can be also independent of Seneca.js. So what is Seneca.js? So it's like a Node.js toolkit for building the microservices architecture. So so in the microservice, you want your application to be like an independent services, like the independent microservices, and this Seneca.js helps you in building that. And so it has some features. So one of the major features within the Seneca.js is that it finds the particular microservice based on the pattern matching. So like if you see in the normal application or normal microservices, you want to search a microservice if it's exposed at a particular endpoint, like a REST endpoint. But this Seneca.js does not use the REST endpoint, it uses a pattern. So we will see what this pattern is about. And then the next is the transport independence. So you can send the messages between services in many ways. So and it's all hidden from your business logic, which is your application microservice logic. And lastly is the componentization, where you would be like your microservices are like a plugins within the Seneca.js. So where you can send one plugin to another person also. So you can do that within the Seneca.js. So how we can write a microservice within the Seneca? So that's done through an action. So action is a function that is identified by a JSON object. And so this is how we create a pattern. So you specify a Seneca.add, and over here you can see this pattern. So this microservice would be using this particular pattern. By pattern over mean, so like it has a role. So role is a book, and the command which I'm specifying over here is find book. So this can be like a high-level API. So like all the books commands goes within this particular microservice. So now from here I can know that this microservice is responsible for finding the book, and your logic for finding that book would go within this action over here, the function. So like simply just finding the book in the database, query the database, get the book, and return back using this done over here. So we'll see more about this in the next slide. And so this pattern or the actions can also be more into the JSON. So like over here, I'm specifying the role as a book. So this maps to the namespace, which I mentioned, like a high-level namespace. And this command is like the what action you want to perform within that namespace, like finding a book or writing a book or something like modifying, updating a book within the database. So all those information you can specify like this. So each one of them can have a separate action, and then that would become as a separate microservice. So now by Seneca.add, we created a microservice, and we can call that microservice using the Seneca.act method. And this Seneca.act requires two arguments. One is the pattern to be matched. So as I mentioned earlier, that we are not using the REST API-based calling, so it's basically based on the pattern. So now Seneca.act over here would see where this pattern is, so the role and the command, and then send this message to that particular microservice to perform the action which we specified over here. So like I can just give you more details. So message we are sending over here, and this is the logic within the microservice, so which has the pattern and the action. So whenever this pattern is matched, this message is sent to this function over here within the arguments itself. So you can see I am decoding the book's ID from this argument, which is passed as a message. And then based on this book ID, I am searching within the database, where is my book, and give me that information and send it back to the done function. So done function is like a callback. So you can see the third argument over here is the callback function, so which takes the two arguments. One is the error and the found book. So the found book over here is this book which we are sending from here. So it would be oversent to this function. And if there is an error, so currently we have null in the error, so there would be no error. So then it will just currently display this book information on the console. So this is how you can write the microservices within the Seneca. So you require two methods basically. One is the Seneca.add, which is the main microservice logic, and the Seneca.act for calling that microservice. So now you can organize these actions within the files. So like you want all my books actions within a single file itself only. So you can do Seneca.add, so like the pattern and then the action, and then you specify the function within within that particular file, and then you can export it and use it within the other application or the same application. So currently, if you see that I am adding two functions within one microservice, but these can be also independent microservice depending on your logic itself. So now, previously we saw that this is the module.export. So I'm exporting this under the books.js. And now in the main file or the main like server.js, you can use this books.js and call the Seneca.act method. Based on the pattern, it will match and then send this information to the microservice. So that's how we can write the microservices within the Seneca.js. So now we come back to what exercise you have to do as part of this. So we have an application where the client is like your browser or a mobile, would send a request to a microservice, which we call it as a server service, and which then is sending the request to another three microservices. One is the hello world, other is the product description service, and the product price service. And these two microservices are attached to a mock data. So currently we don't query to the database. We have these as a files. But we can do it also as a database. But as part of the exercise, these are as a file, so which are only specified within this microservice. And all the three or the four microservices run on a virtual machine, and you will deploy it using the Docker. So whenever, if you query to this particular server service, which is like exposed to the outside world through this API endpoint, so this endpoint has like the virtual machine IP, the port number, the API is the REST API where all my APIs are situated, then the exercise 3, the third exercise, and these two are the parameters. So one is the name, which is the CCS, or you can specify anything over there, and the 3 is the product ID. So this, based on this product ID, we get the product description from this mock data, and from here the product price, and then combine them together over here and send this as a response back to the user. So like the product ID, URL, price, and the name. So currently, as part of this source code, which I will give you, some of the things are missing in this section. So like two microservices over here, so which you have to complete, then deploy, and then check if the solution is successful or not. So how does the code structure looks like? So this is how the code structure is. So it's, if you can see it's divided into 4 microservices, and then we have the docker compose.yaml file for running all of them together. So each of these microservices has a Docker file on its own. So like it's an individually built microservice. Then the hello world.js or a product description.js specific to that particular microservice. And then the package.json file for all the dependencies required for that microservice. And the Docker file and the Docker ignore for ignoring certain files which you don't want to put inside the microservice. And for these 2 microservices, we also have the mockdata.json, which you will read in your microservice to get the product description and the product price and send it back as a response. The last one, the server over here, is the main microservice, which is calling these 3 microservices, and that's why it requires this connection. So this connection where we will be using the Seneca.act method to calling these 3 microservices and combine the data and send back to the user. So how does this mockdata.json file looks like? So it's a data which is mocked for multiple products. So you can see it has the product ID, then the name, URL, the company name, the price, count, and the product number of users liked. So just mock data. And the docker.compose file consists of, you can see 4 microservices. So the server, the hello world service, product description service, product price service. And so you can see that the server is combined, it's depending on the 3 other microservices because it needs to call these other microservices to get the data and send back to the user. And the other interesting part, if you see that these are not exposed on any port number because we are not exposing them to the outside user. So the only to the user is this server service is exposed. So that's why the port number are only mentioned over here. These are internally accessed by this server service. And this hub ID, you have to replace it with your Docker hub ID once you build these microservices. The other interesting part over here, you can see all of these services have the same Docker image, Docker Hub repository. That's a microservice name, but it's only I'm changing the label name over here. So it's good practice to put if you have a multiple microservice for the same application with a different tag name, so that you know that I have a microservice with this name, and it all are part of this bigger application. So like a microservice, then it has a server one, hello, product description, and the product price. So you know that in the one single Docker Hub repository, all will be under the same repository itself only. So now the other important file, the config.js. So this config.js is present within the server. So the server needs to know where all other 3 microservices are running. So like the hello world, the product description, and the product price. And this is the configuration present within the server folder. So you can see that the server is running on the local host for that. And the other ones are running with the host name, the hello world, product description, and the product price. And these are the same as in the docker compose.yaml file. So as you did in the last exercise, if you remember, linking with the MongoDB, so how your application was linked to the MongoDB. So now the server knows that my host name is the hello world service, or the product description service, or the product price service. So if it wants to contact that microservices. So yeah, so now I'll go individually to one of these microservices. That's the hello world. So within the hello world, if you remember the initial Seneca.js examples, it has the same pattern. So like the role is hello world, and the command is welcome. and it says the function which we are calling, if this pattern is matched, is the say welcome. So in the say welcome, we just simply get the name from the user. If you remember, I was sending the name within as a REST API parameter, and that's used over here, and this is returned as a welcome, that name. And now in the hello world, there is an index.js file which makes this hello world microservice run. So within the Seneca, if you do use Seneca.listen, so then the microservice spins up its own instance like a server, and then it starts to listen on the 9001 port. Similarly, for the product description.js file or the product description service, so you get the mock data, and then there are multiple methods or the with patterns and the action which you have to complete. So these are missing within these microservices. So like over here, I'm doing is a role product and get the product URL, and then you have to write this product URL function and the product name function. So what you have to do is read this mock data, find the particular product based on the product ID passed as a message to this function, and then send that as information back to the user. Similarly for the product price. So for the product price, even the method is also missing actually, or the pattern. So you have to write the pattern also. So, and similarly for both the products microservice, you have the index.js file, which says that where these microservices are running. So like on 9002 and 9003 port number. So now we have seen these three individual microservices. Now let's go to the server, which is calling these three individual microservices. So if you remember now within this server file, I have to add the Seneca.act method. So it's like if the pattern is matched, I will call that microservice. So that would be information stored within these three individual services file. So let's see about the hello world.js. So for now, the one thing which is how the Seneca knows where this particular microservice is running. So you have to specify within the Seneca.client function, and it takes two parameters. One is the host name, which we passed as a config file, and then the port number. So it knows now this hello world microservice is running on this host and this port. And now, so that basic information is done. So now if this pattern is matched, so I need to call a particular function or send, and I need to call this microservice and send this name as an argument to that microservice. So this pattern would be sent over here, and then the name would be as a message argument to that microservice. So if you are noticing why I'm doing this object.assign, it simply just combines these two to a single object, and then makes this as a say welcome function, which I am exporting it to be used in the main server. Similarly, for the product description, so now you can see there are two products, there are two patterns. One is a product and the get product URL, and both needs to be calling these individual microservices. And lastly, the product price. So where you have to define the service method, the pattern, and everything, and then export this get product price to the server, where the server would be calling this. So now let's see the main server, which is calling all these three individual microservices. So here you can see I'm importing the services, which includes all the Seneca.act method for individual microservices, and then use these three individual services act method to send the arguments and get the response back. And for that, so there is this router. So as you remember, the API which we were calling was exercise 3, then the name passed by the user and the product ID. So this name is sent to the say welcome function, and the product ID is sent to other three functions which internally are calling to the microservices. And join over here is to use the promise. Can anyone tell why I'm using a promise in this example? So like over here, I used require bluebird.join. So then join, and then joining all the responses over here. But why join? Can anyone guess? Or whoever has used the Node.js, maybe something to do with the asynchronous nature? No? Yeah. Mm-hmm. Yeah. Yeah, it's exactly the same. So he mentioned that so join is doing the, like, it's waiting for the responses from these calls to the individual microservices and then joining the responses back and sending back to the user. So you could also do is do not join. You could individually also send, so it would be like an asynchronous then over here. So currently this is also asynchronous, so like the server service sends a request to these 4 endpoints, so like you can see, and then waits for them to respond back and then join together and then sends back using this combined response to the user itself. No, it's asynchronous over here. Yeah, so you can also do that. So she mentioned that promise all of them and then promisify all the responses together and then send back like over here. So you can also do that. So this is the response which, if you remember in the diagram I showed you, so we were combining the hello, the product ID, the URL, the price, and the product name, and sending it back to the user. So now how you can install and run the application. So it's the same like the last exercise. Download the code. You have to have the Docker and Docker Compose. The Docker Compose is for like Docker Compose up. This will build that. This will not build. It will run the application. But if you run Docker Compose up -- build, it will also build and run the application. And once you have run the application, then go to this particular endpoint to query if it is working or not. And if you get a response with some information over here, then you know that your application is working perfectly fine. Otherwise, you have to debug something. And remember, this product ID you can change. So it's until, if I remember it correctly, it's until 1000. So you can change and see if your microservice is working in that for different products or not. Yeah, and don't forget to enable port 3000 for your application to be working, so that when you access through the virtual machine, the 3000 port is enabled in the firewall rules. And for the tasks, so one, as I mentioned earlier in the earlier presentation, all the yellow markings you have to complete. And that's where you have to complete the product description service to get the product name and the URL, product price to get the product price. So for that, you have to complete these 3 individual files. The 4th is a Docker Compose, where you have to add your Docker Hub ID. Then install the Docker and Docker Compose on the virtual machine to spin up your application. And the same like the last exercise, like build your application on your local environment and then push it to the Docker Hub, then copy your Docker Compose file to the virtual machine, and then again Docker Compose up. It will pull the images from the Docker Hub and then starts to run it. So you can see all your Docker containers using the Docker PS command. So there would be 4 different containers running on the virtual machine. And lastly, you have to enable the Docker Remote API, like the last exercise, so that the Cloud Class Submission Server can get to know which all containers are running on your virtual machine. And the deadline for submission is 2 weeks from now. And for submission is the same as the first exercise. You only have to specify the IP address for your virtual machine where the application is running. And these 2 are the port numbers which you have to enable, the 3000 and the 4243. Yeah. Mm-hmm. Yeah. So the question is whether the virtual machine from the last exercise can be reused again. Yes, of course, because you can just remove the containers and then rebuild the containers with this exercise. Then it should work. Yeah. So that's all from my side. If you have any questions, please feel free to ask.